This video is for October 23rd or October 24th. We're looking at evaluating the arc sine, arc cosine, arc tangent functions, or in other words, the inverse trig functions, and seeing how we can actually use those to evaluate some expressions. Here, I'm summarizing what we talked about on the previous class. If you haven't seen that video, you need to go back, watch that, or else this is foreign. But we talked about the domain and range and the relationship between arc sine and sine, arc cosine and cosine, arc tangent and tangent. And this is really important. The domains for these, yeah, it's important. However, what's really important is the range. The range is extremely important for these functions. And we're going to talk about that right now. So if we look here, the range is from negative for arc sine and as well as arc tangent, really. Here it's just parentheses, there it's brackets, but the range is negative pi over 2 to pi over 2, negative pi over 2 to pi over 2. If we look at the unit circle, which I'm going to pull over here, I'm going to come here real quick. Pi over 2 is here at the top of the unit circle. I apologize if I can't get all of it in. I would recommend getting yours out if you have it, so that you can follow along, make some notes if you want to. So here, pi over 2 and then negative pi over 2 is if positive pi over 2 is here, then negative pi over 2 would be here. So we could even say that 3 pi over 2 is coterminal, if we wanted to, negative pi over 2. And what's happening is, for arc sine and arc tangent, the range is from negative pi over 2 to pi over 2. And we go back to the unit circle, or in other words, from negative pi over 2 to pi over 2. All of this from negative pi over 2 to pi over 2. And what we can notice is that is in quadrants 1 and 4. So if we are evaluating arc sine or arc tangent, because the range is restricted from negative pi over 2 to pi over 2, we're only going to look in quadrants 1 and 4. So again, I'm going to write that for arc sine. We're only going to look in quadrants 1 and 4. And a similar thing for arc tangent, because its range is from negative pi over 2 to pi over 2 as well. And if we look at arc cosine, the range is from 0 to pi. Again, I'm going to take out the unit circle. From 0 to pi, well, here is 0, pi is there. So for arc cosine, we can only go from 0 to pi due to the range restriction. So arc cosine, we're only looking in quadrants 1 and 2, because only in 1 and 2 will we be between 0 and pi. So for arc sine, I'm going to have quadrant 1 and 4. Arc tangent, quadrant 1 and 4. Arc cosine, we're dealing with quadrants 1 and 2. Extremely important. These pieces here are extremely important pieces in terms of evaluating these inverse trig functions. Now that we have that, if you have questions, please feel free to rewind, pause, whatever you got to do. Come and ask me in class. Love it. Love questions. Love to answer them. Now let's evaluate these guys. So let's look here. So if we're trying to evaluate arc sine of square root of 2 over 2, then what's really happening, another way we could think about this, we don't know what's the output yet, but we know what the input is. And arc sine is the inverse of sine. So what's happening is, because these two functions are inverses, if this is the input into arc sine, and square root of 2 over 2 is the input, then whenever I input into sine, the input will become the output for sine, because they are inverses. And again, we don't know what the output is, so we don't know what the input is and is for sine. Excuse me. So we look at our unit circle and try to figure out where on our unit circle does sine equal square root of 2 over 2. So I'm going to pull out the unit circle. We're trying to figure out where does sine equal square root of 2 over 2. Well, we need to remember, if I have the x and y coordinate, my x value is cosine, and sine is my y coordinate. So as I'm looking at the coordinates, let me scoot over a little bit more. I'm trying to find square root of 2 over 2. Well, I see that sine is square root of 2 over 2 here at pi over 4. And it's also square root of 2 over 2 here at 3 pi over 4. So sine would be square root of 2 over 2 at pi over 4 and 3 pi over 4. I'm going to slide this over, come back here. So our question mark could be pi over 4, or it could be 3 pi over 4. However, we need to come back here and look at the range restrictions for the quadrants. And we look at pi over 4 and 3 pi over 4, and we need the one that is either in quadrant 1 or 4. Well, here, pi over 4 isn't going to be in quadrant 1. 3 pi over 4 is in quadrant 2, so we don't care about this side if we're looking at arctangent. We only look in quadrants 1 and 4. And so because pi over 4 falls in quadrant 1, 3 pi over 4 is not a solution, then arcsine of square root of 2 over 2 equals pi over 4. If you have questions, pause, rewind. It's a little bit of a backwards concept to start with, but I think as you get more practice, it comes a little more naturally. Let's look at arc cosine of negative square root of 3 over 2. Similar thing. If we want to relate this to cosine, we need to figure out where does cosine equal negative square root of 3 over 2, because the input will become the output. We're looking at arc cosine, so we're looking in quadrants 1 and 2. If I look in quadrants 1 and 2, again, cosine is my x value. So, and I'm looking for negative square root of 3 over 2. So, positive square root of 3 over 2, go around. Here, x is negative square root of 3 over 2. So, it should be 5 pi over 6. However, it could also be 7 pi over 6 because I have a negative square root of 3 over 2 there as well, since cosine is the x value. But, again, arc cosine, we only look in quadrants 1 and 2. So because 7 pi over 6 falls in quadrant 3, we ignore this. So our solution is 5 pi over 6. I would recommend, if you think you have an idea, try these. And the next video we'll go over these. I'll give you the solutions to the other problems, and then there'll probably be a third video going over the back side as well.